7.3, Part 2, Volumes of Solids of Revolution. The disco method. The disk method. Okay, and once again, you know, we got these notes, keys to the disk method. I'm going to kind of make up my own stuff here in my own notes because I want you to do 7, 8, and 9 on your own. All right, but I'm going to have to fill it in here because I have to use a Google sheet here and able to show you, okay? But here we go real quickly. The disk method is think circle, okay? But I've got my cool website again to show you guys. All right, so what's going on here is this. Okay, so let's say we have a parabola, right? That'd be like x to the x squared, x to the fourth, whatever x squared, like 3x squared, whatever it may be. I think that actually happens to be, well, it depends. They don't give us the x-axis. But if you look here, and if I revolve it about the x-axis, y-axis, I'm sorry. So if I revolve that bad boy about the y-axis, you notice, what does it create as a cross-section? It creates a circle, right? That's what it does right there. Now, what happens if I create these discs or these circles for that entire region from 0 up to 4? What would it look like? Well, check this out. Oh, sweet. You get an object, right? How about it? And what if I asked you to find the volume of that object? Believe it or not, it's just like the questions we did before. It's the area of one of the cross sections. But what is it? Check out this website. You can see that a cross section is a disc, and a disc is a two-dimensional circle, right? And if I revolve it, booyah, you get that beautiful solid object. All right, so here we go. We're going to do some problems here. Okay, when this occurs in AP Calc, we're going to find the volume of objects. But this time, our cross-sections are going to be circles, so we say we use the disk method. Okay, and I have the formula up there, but here we go. You're going to do this on your own. Okay, do those on your own. Okay, you have the solutions, right, that you can look up on Google Classroom. But here we go. We're going to go, here's my example. Okay, my first, we'll call it example A. All right, let's just use y equals x squared. Okay, and let's say we are in the first quadrant. Okay, so we're in the first quadrant, and we're bounded by x equals, let's go x equals 2 and the x-axis. Okay, did I give you enough information? Let's see, let's draw this bad boy. Y equals x squared is this guy. We're in the first quadrant, and I'm bounded by x equals 2 and the x-axis. Sweet. So I'm talked about that right now. Now, whenever we're doing a disk method, I have to tell you I'm going to revolve this about something, okay? So let's revolve this. Let's revolve this. Okay, if you see, it's going to revolve right there, right? Revolve this about the x-axis. Okay, so that's the most important thing you want to pay attention to. If I revolve it about the x-axis, that means everything has to be in terms of x's. Got it? All right. And I think it's kind of important to sometimes draw what this looks like. So the first thing we're going to do is we're going to draw this little, right? That means we're revolving it about the x-axis. Now, what the heck would it look like? Try to visualize, okay? If you had this guy and you just revolved it, what would it look like? It would look like a three-dimensional object that looks like that, right, class? And if I were to slice that bad boy up, if I was to slice it up, this would be a disc or a circle. And it's kind of important to draw that. I'm even going to draw off here to the side, right? Do a little side work. Okay, I'm going to draw there. There we go. We got a circle. Okay, now what is the area of a circle? Well, it's just, right, class? It's just pi r squared. So every single one of these problems that we're revolving it, it's always going to be the same exact formula. That's kind of nice, right? Because the cross sections are always circle. But these are going to be a little bit different from the lesson that we did before. Because for one, if I drew it correctly right here and my pen ran out, how about it? Sweet! Okay, I'm going to try to get this drawn and bring you guys right back. All right, so I think I kind of got us caught up, right, class? But what the heck is a radius of that? Well, if you look right here, the radius would simply be, and you always see, I drew my original graph in red, right? Which means I always use red. Okay, the radius would be top minus bottom. Well, what the heck was the top? We said that was y equals x squared. So the radius of one of these discs would be x squared minus 0, right? Top minus bottom, and that's a radius. So my area here would be pi x squared, because that would be x squared, right? And then I have to square it. So it'd be pi x to the fourth. And then guess what? All I need to do here is the volume is equal to the integral, right? Everything is in terms of x's because we said earlier we were revolving it about the x-axis. And that goes from 0 until what? From 0 until, we went till 2, and they all have to be x's. And then remember, it's just the area of a circle, which is pi. I'm going to bring the pi out because it's a constant. And then x to the 4th dx. And then booyah, right? Just do a little math. Antiderivative of that would be 1/5, x to the 5th, from 0 to 2. Do a little fundamental theorem of calculus, and that would be 32 over 5 pi. Boom! Done! But hey, you know what's cool? Is let's switch this up a little bit. So make sure you're taking notes. I would say maybe make sure you are putting all these on a separate sheet of paper. Once again, you're doing that on your own. Okay, I'm going to use the same graph. Okay, y equals x squared. I'm using the same exact region. Okay, so that's x equals 2 and the x-axis. Okay, but this time I'm going to revolve it about the line x equals 2. Woo! I'm going to revolve it about that. What the heck is it going to look like? Remember, red is the original drawing. It's very important to make sure you keep it in red. You're going to revolve it about that. So that means my object would look like that. Whoa, for reals? Okay. That means it's going to make me think a little bit more. Let's draw what a cross section would look like since it's revolving, it's circular. Okay. And then I do my little side work, right? Do my little side work. That's the nice thing. These problems are all the same. Cross section is a circle, and then the area of one of those cross sections is just pi r squared. So I've got to find the radius. What's the radius? Well, you got to use the red because red is from the original drawing. And if I use the red, the radius would be, revolving it about the x equals 2, which makes it perpendicular to the y, which means everything has to be in terms of y's. And that could maybe mess us up. But if my drawing's correct, right, all of these discs in here are all perpendicular to the y. So it's got to be in terms of y's. And if I look at this, that would be right minus left. Well, right minus left, the right is 2 and the left is the curve. So right minus left, that means the radius would be 2 minus, but I can't put x squared because it's got to be in terms of y. So that's plus or minus, but it would be the plus because I'm in the first quadrant. So there you go. How about it? Okay. And then that just means the area is pi 2 minus the square root of y squared, right, class? So then now I'm just volume is equal to, right, the integral. Oh, it's got to be y, so it's y equals 0 to, oh, snap, I go all the way up to 4. How did I know it was 4? Well, I knew it was 4 because when x is 2, y is 4, right, class? And then it's just going to be pi. Pi is a constant. Bring that bad boy out. And it would be 2 minus the square root of y squared dy. And this would be a calculator one. And you do that bad boy in your calculator. And you get, I got a little 2.667 pi units cubed. Okay, now here we go. Let's switch it up a little bit more. I want you guys to get great at this, and we only got a couple more examples to go. Okay, and then remember to try these other guys on your own. All right, guess what? Same exact graph. Okay, but the thing is, I'm going to change some things about it. There's y equals x squared. But this time, let's go ahead and, let's go y equals 4. Y equals 4 would be that line, right, class? But this time, we're in the first quadrant. Okay, first quadrant. Did I give enough information? I sure did. Y equals 4, and I could even say, and y equals 4 and x equals 0, or the y-axis, right? And that would be this region right here. Now, hopefully you're going to think this about what? This is next level. What could I revolve that about to get something that would give me a disk? Okay, a disk is like a nice solid guy, right? So let's start this guy. Let's revolve it about the y-axis, right? If I'm revolving it about the y-axis, well, that means everything better be in terms of y's. All right, so let's go ahead and draw what the other guy would look like. And remember, when I draw the other guy, I'm going to use a different color because the red is my initial, but there's the y-axis. And if I revolve it, oh snap, I kind of get the other half, right, class? Kind of cool how that happens. Now, if I want to draw a cross section, okay, let's draw a cross section. Booyah, my cross sections are perpendicular to the y-axis, so everything has to be in terms of y's. Ooh, but I'm going to go right minus left, right, class? Right minus left because it's perpendicular to the y's. I come over here, I draw my side, do my little side work two-dimensionally. That's a equals pi r squared. What the heck is the radius? Well, we just said it was the right. Ooh, this time the right is the curve. And the curve is the square root of y, right? Minus the left, and the left is 0. Okay. That's not too bad, right? So I come down here. The area is pi. It's the square root of y squared. Oh, okay. That's pi y. Looks a little, it's almost too simple. Let's see if it works out just as nice. Volume is equal. The integral, well, it's got to be y. So we go y equals 0 to y equals 4. Pi is a constant. Let's bring that bad boy out. The area was just y because we're going to square that radius, right, class? And then it's just dy. Oh, snap, I can do that. I can handle that. So it would just be pi, antiderivative, 1 be 1/2 y squared. Do that from 0 to 4, right? This would be an example of non-calculator. Plug that in, 16. So it's 8 pi. Boom, that's a nice answer. Guess what we're going to do? There's something else I could revolve that by and still get discs as my cross sections. Okay, hopefully right now you're thinking about it. Go ahead and think about it as we draw. Here we go. Your last example for the day will be done in 15. So you better do these other examples. I want to see them in your notes when you come in class. All right, and come in with a lot of questions if you have it. So we're the same exact region. But what the heck would I revolve this by? Okay, so we're y equals, what was it, x squared, we're y equals 4, we're x equals 0, we're first quadrant if we really want to specify everything. But this time we are going to revolve it. The only thing that would give me a disk is where we're going to revolve this about y equals 4. Now you see that y equals 4 and people say, oh, everything's got to be in terms of y. No. Because if I do there's my y equals 4 and I do my little fancy revolving, oh, that is perpendicular to the x-axis, right? I get that object. Draw my little cross section here. My cross sections are all perpendicular to the x-axis. How about it? That means everything has to be in terms of x's. So we do our little handy-dandy side work. Boom. There's my yuck. There's my circle. What the heck is the radius? Well, the radius, since it's perpendicular to the x, and I've got to use the red region because that was the original thing that I asked you to graph, it's got to be top minus bottom, right? So what would that be? That'd be radius would be equal to 4 minus, ooh, I can keep it in terms of x this time. That would be x squared. Okay, that's the way. Okay, I can handle that. So it's area equals pi r squared. So that'd be area equals pi 4 minus x squared squared. All right, let's do work. That means the volume is equal to, no way it canceled out on me. So we are going, oh snap. All right, we're going to try this. We're going to go volume equals, I'm using the finger here. I know some people like this close up. The integral, that would be from 0 to 2, right class, 0 to 2. Pi is a constant, pull that bad boy out. And then we're just the radius squared. So it's 4 minus x squared dx, right? Use that handy dandy calculator and let's see who can get the answer first. Okay, ready, set, let's go. I'm done. I beat you. Right, I beat you. If you do all that stuff, you get 17.067. Math fract that bad boy, and we get 256. Oh, snap. I can't even write on this thing now. We get 256 over 15. And don't forget to add that pi under 15. Go do your work. Aloha.